All right, we're going to do task 1.6. It's called Something to Chew On. It's about this gumball machine. I call it a gumball machine. They call it candy machine. So either way, we'll call it candies, I guess. So here's some of the important information. You should have already read this and tried this. If you hadn't done that, then do that first and then come back to the video. A few important things. Each time a child inserts a quarter, 7 candies come out of the machine. So that's 7 for each quarter. That's pretty important. The machine holds 15 pounds of candy. That's pretty important. Each pound of candy, each pound has 180 pieces of candy in it. So all of those things we're going to need. The first thing it wants us to do, represent the number of candies in the machine for any given number of customers. How many customers will there be before the machine is empty? So, there's a lot of different ways we could represent this. Let's say that N is the number of customers, which would also equal the number of quarters, if you can go along with that. We'll assume 1 quarter per customer, although I know some kids will put more quarters in, and they'll be the same customer, but we'll just do this. 1 quarter, 1 purchase goes with 1 customer. 1 customer, 1 quarter. If we could build a table, and we could have N and F of N here. So we're going to need to know basically at time 0, really, before there's any customers, we need to know how many gumballs or pieces of candy there are. So this would be number of candies, or a number of quarters, however you want to. No, number of candies we'll put there, and then we'll need to build this table. Well, we don't have to build a table. We could build a formula. But in order to even start doing that, we need to know what our starting point is. So they ask how many customers would there be before the machine is empty. And I know that each customer is 7 pieces of candy. So let's see. A full machine, 180 pieces of candy per pound, and there's 15 pounds. There's where we need to go. So the number of candies is going to be equal to, let's see, it's 180 candies per pound, so let's do that. And if we multiply that by the number of pounds, we'll get total number of pieces of candy. So there's 15 pounds in the machine. This is for a full machine before anybody's purchased anything. Units of measure cancel out here. Pounds cancel, leaving us with just candies. So 180 times 15 is actually 2,700 candies. So that means at time equals 0, we have 2,700. All right, we're getting started. At time equals 1, it's not really time equals 1. After customer 1, what's going to happen? What happens with every customer? Each customer takes 7 pieces of candy out for a quarter. So our common difference is going to be minus 7. So the next value here, 2,700 minus 7, would be, what would that, 2693. If we subtract 7 again, we get 2686. Let's go ahead and do 3. If we subtract 7 again, we get 2679, and so forth. I'm not going to do any more of that because I don't want to have to count all those to figure out how many customers there's going to be. I definitely need a formula. So what do we know? We know f of n, our starting point is 0. If we think about that, when we do our recursive, let's set it up with the starting point of 0. F of 0 equals 2,700, and then f of n equals the prior term, f of n minus 1. Remember, this is now equals prior minus 7. That is our recursive formula. Explicit formula we're used to using first term for our explicit formula, so since we already know about the first term, let's go ahead and do that here. F of n equals term 1, 2693 minus or plus the common difference, which is minus 7 times n minus 1. That would be our explicit equation using the first term. But you know what? I would have rather have done that with the 0 term. So here's an important lesson on this one. This part right here is going to equal the term number that corresponds to this value right here. I'm going to write that out. So it corresponds to the starting value. Whether that's the 0 term or the first term, you got to adjust for that. Okay, so this is the first value. This is f of 1, and we use n minus 1. What I could also use, I could use f of 0 and n minus 0. So try term 0. I'm going to use f of 0 and n minus 0. So I'll show you how that works. F of n equals f of 0 minus 7 times n minus 0. Okay, now I'll fill in the actual values. F of n equals f of 0 is 2700 minus 7 times n minus 0 is just n. And so sometimes how we'll write that is just f of n is 2700 minus 7n. Much nicer looking than that. Either of them are correct though. But make sure that you always, if you're using n minus 1, it goes with f of 1. If you're using n minus 0, it goes with f of 0. Those have to match up. And technically, you could use any term you wanted. You could use n minus 3 and f of 3 here. So that's just something we'll be doing more and more of this as we progress. That's kind of bonus land. So now at this point, we could figure out any number of customers, or we could figure out for any number of customer how many candies there would be at any point in time. How many candies would be left in the machine at any point in time. But actually, a simpler way to answer this question, how many customers will there be before the machine is empty? The simplest way to get that, I'm going to put it up here actually, would be just 2,700 candies divided by 7 per person. $270, 2,700 divided by 7 is 385.7. So about 385 customers. Actually 386 I'm going to make it, except the last customer doesn't get a full batch candy. All right, next question is, represent the amount of money in the machine for any given number of customers. So let's think about this. Each customer represents 1/4. And if we express that in dollars, it's 0.25, right? So the amount of money in the machine for any given number of customers, let's have a new function for amount of money. The amount of money would be equal to the amount of money initially, the amount you start with. So that would be, let's use M for money. Money at time 0 plus 25 cents for every customer number. So the amount of money initially is just $0. So it'd be 0 plus 0.25n. The amount of money would just be equal to 25 cents times every customer. All right, that's it. Please work on the homework, page